Hey students, this is lesson 5.2, direct variation. We're going to learn how to write the graph equation of a direct variation. So you really have to know what direct variation is, so kind of pay attention to that. Go ahead and do the review here and I'll check back with you. All right, some important information about direct variations. A function in the form y equals k times x, where k is not equal to 0, represents a direct variation. So it has to be just something times x. Here's some examples. Y equals 3x, that's a direct variation. Y equals 0.25x is a direct variation. Not a direct variation would be something like this. And that's because that is added up. That's not a direct variation. So to determine whether an equation represents a direct variation, solve it for y. If you can write the equation in the form y equals k times x, where k is not equal to 0, it represents a direct variation. All right, so is this equation a direct variation? So we were just told we should solve it for y, and if we can write it as just y equals something times x, no more, then it is a direct variation. Let's divide both sides by 4. And 5 divided by 4, we can leave it as 5/4 x or 1.25x, however you want to do that. And so now we wrote it as y equals some k times x, and that's a direct variation equation. So we're going to say yes. And the constant of variation, constant, let's say COV, constant of variation, equals the number multiplied by x, which is 1.25. Okay, and in the second problem, let's solve this one for y. Subtract 2x from both sides. So we get 3y equals 6 minus 2x. Divide both sides by 3. And we get y equals 6 divided by 3 is 2 minus 2/3 x. This thing is not of the form y equals k times x. There's an extra part to it there. So we're going to say no. And there's no constant of variation since it's not a direct variation. All right, you try that. All right, to write a direct variation equation, we just need to know what the constant variation is. So we need to take this information and figure that out. One thing I'll say, though, is, and you should write this down, if we have an equation, y equals k times x, then we also have the equation if we divide, oops, that y equals k times x, sorry about that, y equals k times x. If we divide both sides by x, we get k is equal to y divided by x. So I can find k by just taking some y value divided by some x value. So in this problem, we are told that it's a direct variation. That's what y varies directly with x means. And we're given one value for y and one value for x that are related. So we can find the constant of variation, k, by just doing y divided by x. And in this case, y divided by x is 40 divided by 8, which is 5. So my constant of variation is 5. So my equation is y equals k times x, and I know that k is 5, so I'll just substitute 5 for k, and there's my equation. Now it says, what is the value of y when x is 12? Well, for that, I'll just substitute 12 there with the x, and I get 60. So when x is 12, y is 60, and that fits this direct variation situation. Go ahead and try that. All right, graphing a direct variation. Suppose $15 US is worth about 150 Mexican pesos. Okay, and so this amount of pesos varies directly with the amount of money you have. The the more US dollars you have, the more pesos you get. And it varies proportionally. So, so let's figure out what that is. And remember that our constant of variation is equal to y divided by x. In this case, our pesos is y, so that's y. And our US dollars is x. So we're just going to take 150 divided by 15 to get our constant of variation, which is our exchange rate here. So you get 10 pesos for every dollar is basically what we're saying here. So my equation is the number of pesos is equal to 10 times the number of dollars. All right, and then to graph that, 0 pesos is $0, or $0 is 0 pesos, $1 is 10 pesos, $2 is 20, and so on. And once I see the pattern, I know it's linear, I'm just going to go ahead and draw in that line right to the end there. All right, and that's how you graph a direct variation. All right, do you try that? I just want to explain how I'm graphing this. There's kind of a shortcut you can do. Direct variation graphs always start at 0, 0. We'll find out why in a second here. But and we know that they are linear, so all you need is one other value. I'm going to choose an easy one here. When x is 100, y is 17. So I'm just going to go up and put a value there at 17. And then this is a continuous situation, so I'm just going to draw a line between those 2 points, and I'm done with my graph. All right. So a little concept summary here. Graph of a direct variation, y equals k to x is a line with the following properties. The line passes through 0, 0. The slope of the line is k. If you substitute x equals 0 and y equals 0 in the equation, it should be true if it's a direct variation. So let's just check this out here. Let's put in 0 for x, 0 for y. We get 0 plus 0 equals 3, and we're going to say, no, it doesn't, because the graph of negative 2x plus y does not pass through 0, 0. The equation is not a direct variation. So, writing a direct variation from a table. So, in order to be a direct variation, you need a constant of variation. So, you always need to get the same number when you do y divided by x. And so it's easy to tell in a table if it's direct variation just by dividing y by x for each of the values in the table. So if we do 5 divided by 2, we get 2.5. 15 divided by 6, we get 2.5. 25 divided by 10, we get 2.5. So yes, this is a direct variation. Our constant of variation is 2.5. So the equation y equals 2.5x fits this table. Go ahead and do table B, see what you think. Divide each of the y's by x and see what you get. As you can see, you do not get the same number when you divide y by x for each of the values in the table. So even though this is linear, it's not a direct variation because there isn't a constant of variation. So there's no constant variation here. All right. Go ahead and try that. All right, so that's the end of the lesson here. Go ahead and do the lesson check, and we'll talk about that next time we meet in class.